that we just got done with the cardioid shape. Go ahead and try this. Try these out on your calculator or on decimals and fill out the information. Once you're done, you can hit unpause and fill out the limacon without an inner loop definition. Okay, again, so this is red. Limacon without an inner loop. So we will have equations. R equals A. We can have plus B sine of theta or A minus B sine of theta. And then we can have the other one, R equals A plus B cosine of theta or minus. Okay, so those are the equations that we can have, where A and B must be positive, and A, this is important, A must always be bigger than B to be a limacon without an inner loop. Okay, the graph of a limacon without an inner loop does not, okay, so does not pass the pole. So when you're graphing it out on your calculator or on decimals and you're starting to sketch it out on your paper, do not go through the center. So now let's go to 1F. So just like the cardioid, we will do this test for symmetry by hand, okay, symmetry test by hand. We want to start with the very first symmetry. So that was symmetric with respect to the polar axis. And write it down of what you're about to do. Replace theta by negative theta. So R equals 3 minus 2 sine of now negative theta. As you know already, sine is an odd function, and odd, here we go. Odd functions mean a negative angle is the same thing as negative f of x. Whoa, f of x. That was tricky. Okay, so I do have a negative theta is not the same as cosine. You can't just make it disappear. You have to bring it out to the front. So if you bring it out to the front, it's like this, right? I have another negative. So now sine of a positive theta. Well, if you look at this, this is not identical to the original. So right now we know for sure it is not symmetric with respect to the polar axis. X it out. Next, we want to see if it's at all symmetric with respect to the line. Theta equals pi over 2. So the formula said replace theta with pi minus theta. Okay, then let's rock and roll. R equals 3 minus 2 times sine of pi minus theta. We will use the sum and difference of sine. So 3 minus 2 quantity. We are going to spell it all out. Are you guys ready? Sine of pi cosine of theta minus cosine of pi and sine of theta. Just like that. Well, sine of pi, that will go away because it's 0. Okay, so R equals 3 minus 2 quantity. Cosine of pi is a negative, and there's already a negative in the front, so that becomes positive cosine. Sorry, that becomes positive 1, and then times sine of theta. So here's what I got. And that means this is exactly the same as the original. So we can say that this is definitely symmetric about the line theta equals pi over 2. I will get a highlighter and I will highlight that because it's exactly the same. Now I want to do symmetric about the pole to see if that's true or not. Okay, so the pole said replace R by negative R. And immediately you can tell that it's not going to be symmetric, so we can just X that out. All right. So based on what we just studied or wrote down the definition for limacon without an inner loop, right? Look at your A. Your A is 3, your B is 2, and A is bigger than B. So this is a limacon without an inner loop, okay? Okay, so now let's use decimals to help us out with this graph. I will now flip my computer. So I will erase the cardioid and enter in your r equals 3 minus 2 sine of theta. All right, so as you can see, it is definitely not symmetric about the x-axis, aka the polar axis, but it is symmetric about the y, aka the line theta equals pi over 2. Okay, as you can see, the origin, would you agree that it does not run through the origin? But it looks almost like, right, like a lazy heart, okay, or almost like a bean, okay? So what we want to sketch that out is the 3 pi over 2 looks like you have all the way down to -5, -5. So we're going to plot that. So let's see, 0, 3. Okay, so I want to plot all of those dots. 0, 3, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is also 3, and I want to see what's pi over 2 comma, what was the radius for that one? 1. Okay, so pi over 2 comma 1. Okay, so the shape looks like it goes out a little bit, and then it loops back all the way here, just like that. That's some ugly limacon. Oh man, I'm gonna try that again. I'm gonna flip my computer back. That's really ugly that I just, okay. Let's see if I can make it Y. Wee, down, okay. And then up, wee. Well, the right side's a little bit better than the left. I missed some dots, I make it really fat. As long as you don't touch the center and all the major axes, positive x, positive y, positive, negative x, negative y, has all those dots, we are good.